one.
Hello, everyone, and welcome to Lab Manager's Tech Trends webinar series. My name is Trevor Henderson, and I'll be moderating today's discussion, which focuses on forensic science tools and technology. We like our webinars to be very interactive, so we encourage you to send us your questions at any point during the presentation, and our panelists will address these during the question and answer session following the slides. To ask a question, simply type your query into the question box, which is located on the left-hand side of your screen. We'll try to address as many questions as possible during our time together, and if we happen to run out of time, I will forward any unanswered questions to our presenters and they can respond to you via email. Additional resources can be accessed through the resource window, which is also located on the left-hand side of your screen. And just a reminder that this webinar recording will be available early next week on Lab Manager's website. At the end of the webinar, we'll share that link with you, as well as the contact information for our panelists. With that, I'm pleased to introduce today's speakers who join us from LabConco Corporation. Kelly Williams is the LabConco Forensic Product Manager. She has over 15 years of experience developing laboratory equipment and providing application support. Kelly has a passion for developing equipment that makes laboratory work easier or produces better results. She's helped hundreds of labs from all over the world select equipment for their needs. Also joining us today is David Wasesha. Dave is a product manager for LabConco's hazardous powder containment products and works closely with agencies including the state and federal law enforcement, along with major pharmaceutical companies, to minimize exposure while handling highly potent compounds through the use of powder containment engineering controls. Thank you both for joining us today.
Thank you, Trevor. We're really happy to be here. And like Trevor said, today's webinar is going to be on laboratory equipment specifically for forensic sciences. We've had the pleasure of being involved in the planning and construction and renovation of many new forensics or crime labs all over the country over the past 5 years. And we definitely have noticed some trends that we are seeing. And we wanted to share those trends, but more specifically, we wanted to share how those trends are affecting the equipment that we're making and how the equipment is changing to meet those demands. The first trend that we're seeing is the need for greater protection of laboratory personnel. It's people no longer want to put themselves in harm's way, and it has become very important for people to protect themselves. Lots of the equipment we make does provide personnel protection. And what we're finding is even things that people used to do on the open bench now, they do want some sort of ventilation or some sort of enclosure to protect themselves. Another trend specifically for forensics labs is we see people wanting increased evidence protection. The analysis of the instrumentation has become so sensitive that it doesn't take much to cross-contaminate or get high backgrounds in samples, particularly when we're talking DNA. So there is a lot more concern about evidence, maintaining the integrity of that, and also protecting that evidence from being not pure. Lastly, especially when it comes to renovations or new lab construction, we're seeing an increased demand in sustainability. People want to lower their operating costs. They want to use less energy and be more sustainable in their laboratories. It is kind of interesting because generally increase in personnel protection and an increase in the sustainability can be in opposition with each other, because in order to protect you, generally you're moving more air away from yourself. So equipment has changed quite a bit, and we will go into specific how that equipment has changed in order to accommodate both those goals that appear to be in opposition of each other. The first product that the equipment that we're talking about, specifically in forensics equipment, or forensics labs is biological safety cabinets, PCR enclosures, fume hoods, evidence drying cabinets, super glue or CA fuming chambers, fingerprint powder stations, and also powder containment hoods. The powder containment hoods within the past year or 2 years and a half have become a very hot topic as the fentanyl issue and protecting personnel has become a hot button. So we are going to be addressing how to work with fentanyl as well as in this presentation. The first item is an evidence drying cabinet. Evidence drying cabinets have become a forensics lab stable. They are really important in the job that they do. I know a lot of labs may still be drying their evidence in a shower stall or in a fume hood, and there are a lot of reasons why they would not want to do that. So what exactly makes an evidence drying cabinet safe and effective? The first thing is we're going to put a HEPA filter on the exhaust. If you're drying evidence, more than likely that it is wet from a body fluid, and that evidence is a biohazard. So just putting it in a shower stall with not HEPA filtered ventilation is can be blowing a biohazard all over. You definitely are going to want a HEPA filter on the exhaust to contain that biohazard. The other thing that an evidence drying cabinet has is a carbon filter. And the carbon filter is there to simply eliminate any odors that may be present. Chain of custody is important. It's very important to maintain chain of custody with the evidence. And an evidence drying cabinet gives you a nice way to lock and secure your evidence. A lot easier than locking and securing a fume hood, that is for sure. We also are not only protecting ourselves with an evidence drying cabinet, we're protecting our evidence. There's pre-filters on the doors, and it will pre-filter the air coming in to prevent any cross-contamination or simply contamination of that evidence. So we're filtering the air that's coming in, and we're filtering the air that's coming out. One thing that you're going to want to consider when you are looking at evidence drying cabinets, because you are putting biohazards in there, you're going to want to look at how easily that cabinet can be decontaminated. It's not just simply cleaning an evidence drying cabinet, but you're going to want to decontaminate that. You're going to want to kill any germs or viruses that may be around. The other thing that you're going to want to do is ensure that your environment, when you're done with your cabinet, is DNA-free. The last thing you want to do is move evidence from one case into a cabinet that has DNA from another case. So two things that we have developed in our equipment to respond to these needs is the importance of DNA and DNA-free environments, as well as the ability to clean them, are stainless steel interior and a UV light. And I'll get into that just a little bit further in a minute. Evidence drying cabinets come in a variety of sizes. So you can get multiple small units for labs, or if you're not processing that much evidence, you may consider simply a benchtop unit. The 3-foot unit is by far the most popular, but every new construction project that we're working on will also include a 4 or 5-foot evidence drying cabinet for the ability to dry larger pieces of evidence. We commonly see evidence drying cabinets banked together, and if it's new construction, there will for sure be an evidence drying room. These evidence drying rooms are usually adjacent to the triage area where the evidence first comes in. And the important thing is to minimize the movement of evidence. You want to be able to receive the evidence and put it into the cabinets to protect your personnel and the evidence itself. Generally, when there is an evidence room, these cabinets pictured here are ventilated, so you have the choice to keep them in their ductless format that's standard, or you can get an exhaust kit as an accessory that will vent them to the outside. That will use a little bit more energy, but for some labs, they prefer that. Generally, when you are doing new construction is when you have more choices in what type of exhaust you're using. Materials of construction. Like I mentioned, we firmly believe that the interior should be a stainless steel liner. We also make biosafety cabinets, so we are very familiar with decontamination and the use or the handling of biohazards. If you look at other industries such as food or medical, they're consistently using stainless steel. It is seen as the golden standard in the ability or material to be decontaminated. We also provide a UV light, and the stainless steel holds up a lot better to the UV light and germicidal cleaners. For durability and long life, the stainless steel is a superior material of construction. I mentioned the UV light. The UV light has two purposes. First of all, it's going to provide secondary decontamination. You should never use UV as the primary decontamination. It should only be used after you thoroughly decontaminate the cabinet after use. But UV is great for secondary decontamination, and it also denatures DNA. So it's really nice to use this UV light to ensure that when you're done with that cabinet, it's deconned properly, the UV light's been on, that you can be assured that your cabinet no longer has DNA in it when you move your next case. One thing that we wanted to make sure was that people could not accidentally load their evidence in and then accidentally turn on the UV light and forget and just simply turn the light on, because that would denature the DNA that's on the evidence, the last thing that you want to happen. So our cabinets have incorporated a UV light security lock with their light, and that requires a key, and the key to be in the on position before the UV light will come on. We recommend that the key be kept by the person or personnel that are cleaning the cabinets, and certainly not just left in the on position, as it does have a specific purpose. The next room in the or area discipline in a forensics lab that the equipment has changed in recent years is the latent print area. Generally, in this section, you're going to find CA or superglue fuming chambers, fume hoods, DFO chambers, fingerprint dusting stations. Most of these labs will also include a large sink with benches and tables. And one thing that's important in this part of the lab is to have proper ventilation. A product I specifically want to talk about in the latent print section is the CA fuming chambers. Recently, this is our Capture BT that we recently introduced to the market, and we spent a lot of time studying the CA process and how forensic scientists work in order to provide a cabinet that would do what we felt would be the best processing of the prints. Excuse me. Automated CA fuming chambers have many advantages over the old method of fish tanks and coffee cup warmers. Some of those advantages are certainly the quality of the prints, the consistency of the results. One thing that we wanted to do was give parameters that you could see and give feedback that your hot plate was the temperature that it needed to be with readout, and your humidity levels were the levels that they needed to be. Without that readout, you have no idea from day to day if your parameters are consistent. So consistency is definitely a feature of the CA fuming system. Another thing is that it frees up personnel. It's automated, so no one's required to stand there and monitor the process. And lastly, safety personnel. These cabinets are ventilated and they're also filtered. So the filtering system tracks the amount of runs that have occurred and gives you warning of when filters need to be replaced, as opposed to the old aquariums where you simply would turn your head, lift the lid, and breathe elsewhere. These chambers definitely reduce the exposure to CA fumes. The CA process itself is can be tricky, and it's more like an art form to get good prints. And it's all dependent. All these factors that go into the quality of your prints are dependent on each other. So for instance, how much glue you use in the tin, the type of glue that you use, the temperatures that you're setting your hot plate to, and also your fuming time. If you raise the temperature of the hot plate, you're probably going to fume a little faster. If you lowered it, you're going to fume a little slower. So all of these are very important in the quality of the results that you get, and they're also interdependent on each other. When you change one, you're more than likely going to need to change another parameter to accommodate it. So as you have this process that is very dependent on different parameters, it's really nice to have an automated fuming chamber that will automate the humidity level, automate the heating of the CA, and automate the fume exposure and the exhaust. They make your results to get high-quality prints. It makes it very easy to reproduce and have high consistency in those high-quality results. When you're looking at different cabinets or chambers, you're going to need to look at how protocols are developed, how they're stored, what types of features that cabinet has or that fuming chamber has. Are you able to add more minutes in the middle of the process if you see that your prints aren't developing properly, or do you have to start back from the beginning? Are you able to walk away and not have to be there right when the process ends? Different things like that will directly affect your experience using this product. And so it's important to consider these press and play type features as you're looking at your chambers. Air circulation is important in these chambers. You want to know how that air is moving while it's fuming. If we just loaded a large area with our evidence and had a hot plate with glue and no air movement, the evidence closest to the hot plate is going to become more exposed than the far corners of your chamber. So air circulation and how the air is moving during the fuming process is really important, as well as in the exhaust. So you're going to have filters and air moving, and knowing how that is happening and what is going on, and is important to ensure that you're purchasing a cabinet that is going to give you the results that you need. Humidity level. Humidity level is critical in getting high quality prints. The optimal humidity level is between 70 to 80% humidity. Obviously, how long it takes for your automated system to reach that level is going to vary depending on the relative humidity that you're starting out with. A fuming chamber being used in New Orleans in the middle of the summer is going to have a different humidity level time requirement than a cabinet being used in Phoenix. So the important thing is that you get a consistent humidification, that this can happen rapidly in your process, and that you have some flexibility. If you are fuming and you're not reaching the proper humidity levels, your prints aren't going to be fixed. They may look fine, but they will wipe off as powders. As in any process that you're doing with equipment, it's important that you can calibrate that parameter. So as over time, the humidity level readings may change, and you're going to want to make sure that you can calibrate both your hot plate and your humidifier with reference tools that themselves have been calibrated. So that's a very important process that you can go through to ensure that you're getting consistent results. Another thing to consider is accessories. When you have a fuming chamber, what accessories are there to make the processing of certain evidence better? What's the diagonal of your cabinet? Are you able to put in long items? These are all things that should be considered. The cleanability. Is your fuming chamber cleanable? Cleaning a fuming chamber is really important. As the CA deposits build up, they will need to be changed. And the more frequently you use the chamber, the more frequently it's going to need to be cleaned. So how easy is that chamber to clean? Another trend that we're seeing is, and this is taking the science a long time to get there, is we've been working a long time, or they've been working a long time on being able to get a cyanoacrylate glue that will also fluoresce. So in order to make the process of prints into one step, where you're combining the fuming process with the staining and dyeing process. And recently there has been a product out of Europe called Cyano that's been very effective at doing that and producing excellent prints, as you can see here. So if you're using Cyano or some of the newer super glues that are incorporating dyes and stains, a lot of these have higher temperature requirements or tighter specifications on the conditions that they will be optimal on. So it's important when looking at fuming chambers that you make sure that you're purchasing for the future and that your chamber has the flexibility to take these new glues and accommodate these changes as they are happening in the science. Lastly, other things to consider are how easy is this fuming chamber to use? How repeatable is it? Am I going to be able to change my parameters if it changes down the road? Am I going to be able to use the new glues? How much time is required for a run? Is my fuming chamber protecting my evidence from overexposure? What are the maintenance requirements? And also, how is the manufacturer's ability to support and service those? Those are all factors that should be considered when looking at fuming chambers. The next product that I will address in the latent print area of the forensics lab is the high-performance hoods. We have seen a greater need or increased demand for personnel protection and that increased demand for sustainability. Lots of times both of these demands can be made with a high-performance fume hood. What makes a fume hood high performance is its ability to contain with less than or at 60 feet per minute in air volume. Traditionally, fume hoods run at 100 feet per minute, while a high-performance hood will contain as well, if not better, than the traditional fume hoods, and they will do that at 60 feet per minute. So right there, by running at 60 feet per minute, you are reducing your energy consumption by 40%. If you look at most laboratories, whether it's forensics or just science labs in general, as far as the operating cost of the building or facility, fume hoods are by far one of the biggest expenses in those operating costs. If you have a traditional fume hood, And this will vary depending on where you are in the country, because it will depend on how much money you're spending to heat and cool the air that's going into your laboratory. But an average overall for the entire country, by replacing your regular fume hood with a high-performance fume hood, you're going to save around $3,900 per year, and that's just average. In some, if you combine that with an air volume, a variable air volume system, you could save up to $6,800 a year per hood, and that is per hood. So if your lab has 5 hoods, you can take that times 5 every year. So lots of times these high-performance hoods may be a little more expensive to start off with, but in the long run, they're going to end up saving you a lot of money in operating costs. Filtered fume hoods and enclosures are another area that we're seeing an increased demand. Again, with these, they have higher initial purchase price, but you are not exhausting anything out of your building. So your energy savings can be phenomenal of what you're exhausting. The downfall to these hoods is that you're going to want to make sure that what you're doing is compatible with the filters. The filter fume hood manufacturers do offer a free test where you fill out an evaluation. They can tell you if filters are going to work well, and for the most part, how long they're going to last you. So that is something definitely to consider in your laboratory if you're worried about sustainability and increasing your personnel protection. Many times if the building is already built and there is not, with a filtered fume hood, you don't have the expense of a duct run or a remote blower. So they can be, that can offset their initial purchase price. Along with that ductless or filtered thought pattern is our fingerprint powder stations. Traditionally, people use fume hoods for fingerprint powder stations. And what would happen is they would go to the fume hood and start powdering their evidence, and the next thing you know, there's black powder all over the hood and the crevices, and as you well know, it may be very hard to clean that. And so then that becomes the powder hood, and no one else really wants to use that for their processes. So these fingerprint powder stations are very effective on fingerprint powders. They're ductless. So again, this is an energy savings, and it also will free up a fume hood for other uses in your lab. Those are the products I'm going to talk about. I'm going to turn it over to Dave, who is going to address the very important topic of containing powders and what types of enclosures are available for that, and really how you should handle these high potent powders. So here you go, Dave.
Hi, everyone. Thanks for joining us today, and thanks to Kelly for running through the forensic products. I'm going to talk a little bit about a group of products that we make that are designed specifically to contain hazardous powders, and they kind of were born out of the concept of a fume hood, and then it had evolved over time as the pharmaceutical industry became more aware of potency hazards with their hazardous powders. So here's a picture of representation that you may have seen before. It's looking at lethal doses of some common drugs that are picked up from crime scenes and during drug confiscations. So these are all lethal doses, and you can see heroin, a very common drug, a pretty decent amount of powder for a lethal dose, but as you scooch down to the right, you're looking at very small specks of dust in the fentanyl and then carfentanil containers that are required to cause a lethal dose. So there are a lot of ways to handle these drugs that are safe, but before we get there, we're going to address just some common mistakes that are frequently seen in laboratories that are not well suited to handle these compounds. First one is handling these on the open bench. So our friend here, Al Pacino, just exposed a little bit more open powder than we typically like to see. Obviously, not a condition that you want to be put in every day. You have to go work with hazardous powders. Here's another picture actually from a laboratory handling fentanyl powders and other hazardous drugs. Now, hard to say exactly what's going on here, but if you're handling fentanyl or other hazardous illicit substances on the open bench, there are a lot of opportunities for you to expose yourself in ways that may be hazardous to your health. So here are just a couple of quick highlights for concern. So the respiration mask, while sufficient, could be improved to a true HEPA filtered mask with P100 filters. You can see the woman's weighing out powders right here on the open bench. When you're doing that, you're bringing energy into the process and causing the powders and particulates that you may be testing to be aerosolized or flung into the environment in which you're occupying. You also notice a couple other consumables and materials that are easily coated in hazardous drug powders, and sometimes it's easy to, on your way over to toss them in the waste stream, you can drop some of the powders off onto the floor or onto your coat, or places where powders should really not be left. Another way to improperly handle fentanyl or other drugs is inside a fume hood. So fume hoods are really great at removing chemical vapors. They're gases that are ejected into the airstream far above a building where the fume hood exhaust terminates. But if you're dealing with powders such as fentanyl, those powders are going to eventually settle down somewhere after they've been ejected. Unlike a gas, they have a mass and they want to settle thanks to gravity. And that can mean that they could be on the rooftop or perhaps in the parking lot next to the building. Also, another really big cause for concern, especially for your facilities people who may be working with the maintenance of the blower on the rooftop or changing the ductwork at a later date. All of those powders that you'll be weighing will go into the ductwork and contaminate that entire run. So if you were to ever come in and adjust that in any way, you would be at risk for exposure to all of the things that would have been handled inside that fume hood. Fume hoods also run typically a lot faster than some of the powder containment hoods that are more ideal, running at about 100 feet per minute, as Kelly had kind of touched on. If you're moving air that quickly, it can often lead to a situation where the powders are distributed and flung off of your weighing spatula or easily brushed away from the container that you've opened with a hazardous drug sample in it. Ductless hoods. I've seen a lot more comments about ductless hoods being used to contain fentanyl and other hazardous drugs. Traditionally, the word ductless hood is in reference to a chemical fume hood with carbon filters in it. So the ductless hood here is using carbon filtration in an end goal to capture vaporous chemicals. Hazardous drug particulates have a mass in a powder, and they rely on a particulate filter, which would be a HEPA filter, or a high-efficiency particulate air filter. So if your hood is a ductless hood and only has carbon filters, the likelihood that you'll be able to trap all powders flowing through it is very low. You absolutely need a HEPA filter to trap dust and powders from hazardous drug samples. Much like fume hoods, ductless fume hoods are often set to run a little bit higher than desirable speeds for handling powders, so it can be difficult to contain them when you're pulling up a sample on a spatula. I see a lot of, just in general, a lot of different hoods called ductless hoods advertised for fentanyl use. If you have one of these hoods or if you're investigating them, you definitely want to make sure that you're working with a hood that's going to have a HEPA filter for those powders. There are a couple of solutions to handling hazardous potent drug compounds, and they come in a couple of different formats depending on your comfortability with handling, how much drug you're handling, what you have for space. Our products are called the XPert System, which is a small HEPA-filtered enclosure, much like a fume hood format with a glass sash. We also have glove boxes and a couple of other specialized hoods that have more HEPA filtration built in. The first and probably most common hood used for fentanyl containment is an XPert System. And what this is essentially a negative pressure hood that's pulling airflow away from you, so it's protecting yourself. It's drawing any powders that you might be exposed to normally on an open bench away from you to the back wall and then embedding them on a HEPA filter inside. The HEPA filter has what's called a bag-in, bag-out system built in, so when it comes time to change that filter out, you can quickly pull that contaminated HEPA filter into a sealed bag, protecting yourself, protecting your laboratory environment from anything that might have been collected on that HEPA filter surface. That's a really important feature of the HEPA filtered enclosure, that's the XPert System. There are other HEPA filtered enclosures out there that may not have bag-in, bag-out systems built into them to protect you or whoever might be changing that HEPA filter out when it's fully loaded. XPert Systems also have airfoils and a baffle which helps smooth out air and reduce turbulence so that the powders won't have a risk of flying back out of the hood. We also know that these hoods contain really to an extremely low level using a company, an industrial toxicology company known as SafeBridge, which typically works with large pharmaceutical customers. They actually stress tested our hoods to ensure that they would be containing powders during typical operations of unpacking and weighing. These hoods are also generally quite easy to install because they're not ducted. Most pharmaceutical powders are not anything more than an inert white powder, so they simply they can be filtered on a particulate scale, and air from that filter can then be returned right back into the room without needing expensive ductwork and energy costs associated with removing air. They come in a lot of different sizes as well, as small as 2 feet, so if you have a really tight space but you need this protection, you can certainly squeeze one of these hoods in. And they they come up all the way to the 6 foot width as well for evidence such as large boxes or packages that you might not be sure are contaminated. So put them in a big hood and you have a lot more work area to be able to be protected. Airflow through the hoods works very much like a fume hood. It's smoothed out using the airfoils at the entry of the hood on the left side. And as it flows away, it's going to carry any particulates away from you and back into an area where they're safely collected and contained on the HEPA filter. There are options to have extra HEPA filters. If you're particularly cautious, you can certainly buy one of our double HEPA filtered hoods. And it just has redundant HEPA filters, each with bag-in, bag-out for extra protection. And the last hood that's frequently used for fentanyl containment is a glove box. Our precise model is a HEPA filtered model that is completely sealed off. So if you're working with a package that you have concerns about, perhaps when you unpackage it, it's going to create a large amount of dust, or if an operator is not particularly comfortable with working with their hands directly on a sample, they can use a precise HEPA filtered glove box to protect themselves and have a complete physical isolation barrier between themselves and the samples that they're working with. This also has a HEPA filter with a bag-in, bag-out kit on it, so you can safely remove that HEPA filter when it becomes fully loaded. So those are 3 options for fentanyl containment that provide HEPA filters with bag-in, bag-out safe changing and really give a simple benchtop solution to the issue of hazard containment with fentanyl and other hazardous drug powders. So I just want to thank you guys all for your time. Kelly and I will be available for some questions now. So please feel free to submit them and we'll answer as many as we can in the time we have left.
Excellent. Thank you, Dave. We do have a number of questions that have come in for the audience. And for those that may have joined us late, you can ask questions of Kelly or Dave simply by typing your query into the question box, which is located on the left-hand side of your screen. So our first question says, we are renovating our lab space and would like to have our evidence drying cabinets vented to the outside. Sometimes they get bad smelling items to dry, and venting is what they would prefer. Can this be done?
Yes. Our evidence drawing cabinets, you can use them in a ductless format. That's how they come standard. But you also can order an exhaust accessory kit where they can be ducted to the outside. So either way, you can use them. Either way you would choose. Good question.
Excellent, thank you. Now, Dave, I think this next question might be for you. It says, I didn't realize the difference in hoods. I thought a hood was a hood. If we were to get a powder containment hood for our powders, could we use that hood for chemicals as well?
If you were to get a powder containment hood, you would definitely want to make sure it has a HEPA filter and a bag in, bag out set up firstly. If you need to use chemicals, so for instance, if you're diluting a fentanyl sample for analysis on like HPLC, obviously you're going to have a solvent at play in that hood. And to safely protect yourself from the solvent, which is the chemical vapor, or will emit a chemical vapor, you would want to duct that hood out. All of our powder containment hoods can be ducted to the outside, just like a traditional fume hood for safe removal of vapors.
Excellent, thank you. Now our next question asks, with the ability to adjust several parameters at the same time on the new fuming chamber and the temperature setting and time of the runner dependent on each other, how do you know where to begin to make adjustments?
That's a really good question because all those parameters, one affects the other. On our fuming chamber, they do have 3 default programs that can be edited, but it will always default back to those. And those are parameters that we know for sure that will work. The first one is low temperature, the second one is a high temperature, and the third program is parameters that are perfect for Lumi Cyano. So no matter what you do on our fuming chambers, there are 3 specific programs that will always work. So even if you can edit them and change them, but you can always, they will go back to those defaults, so you don't have to worry about that.
Excellent, thank you. Well, I thank you both for your presentations today. And this brings us to the end of today's webinar. If you have any further questions, please consider reaching out to Kelly or David directly, as they are the true experts in the field. And their contact information, as you can see, is available on screen now. And just a reminder that today's webinar was recorded, and you will receive an email with that link when the on-demand version is available. On behalf of Lab Manager, I'd like to thank Kelly and David for their excellent presentation, as well as Lab Conco Corporation for sponsoring this Tech Trends webinar. As well, I would like to thank all of you for taking time out of your busy schedules to join us today. If you'd like to learn more about all of our upcoming and on-demand webinars, or to find out more about the latest laboratory tools and technologies, I'd invite you to visit our website at labmanager.com. We hope you can join us again. Thank you, and have a great day.